Hello. So, yes, I should be live. Hopefully you can also see the video. Yes, you can also see the video. And hopefully the screen also moves. Why isn't it moving? This is concerning. No, okay, now it is. Okay. So I've had a few technical problems with some of the past videos. As some of you noticed, the microphone was very low, so I hope I fixed that with the powerful tools that I have at my disposal. So let's just get back into it. So we are now at episode 6, I believe, of me trying to learn Rust in like live on YouTube. Actually, I am also going to go to a Rust event in the city I'm in next Wednesday, so that will be kind of interesting, and I hope that after all these episodes I can actually understand a few of the things that will be discussed in this event. Yeah, so let's just get into it. So last time we looked at the slice type, and today we're gonna look at structs to structure related data, aka the like Rust version of Java classes, I guess. Let's see. So struct or structure is a custom data type. So yeah, it's a way to define a new type, like string or whatever, that lets you package together and name multiple related values that make up a meaningful group. If you're familiar with an object-oriented language, we definitely are, a struct is like an object's data attributes. Interesting. Why just the attributes? Oh, so maybe it cannot have methods? Does the struct only package together a name and multiple related values? So maybe a struct does not have any methods. I would not be against that, to be honest. We try to write Java in a very like functional way at work, I would say, like so that we have auto value that are data classes, which would be basically what struct in Rust are, if I understand correctly. They usually don't have methods, or let's say they don't have business logic methods, and they are just immutable objects that move around, and then we have like a more functional state code to actually process these auto value and other like user generated stuff. So yeah, classes were a mistake. So in this chapter we compare and contrast tuples with structs to build on what you already know and demonstrate when structs are a better way to group data. Of course, yes, we already looked at tuples in a few episodes back, and also arrays, if this is the name, I guess so. Yeah, I think in data types, didn't we see tuples? Yes, and arrays. Yes. So let's refresh a bit what tuples are. Okay. So basically, also with tuples, you can group together data. Interestingly, you can do that with different types. So, for example, you don't need to have like you can have multiple types in a single tuples, like in this case. So I guess the reason why structs are better is because tuples don't really let you name things. Like, what is this 32-bit integer? We have no idea. So I guess we would use structs when we want to name this grouping. Otherwise, a tuple is fine. Probably, I would say that the times in which a tuple is fine are very low, are very few, but who knows? Okay, so we'll demonstrate how to define and instantiate structs. We'll discuss how to define associated functions, especially the kind of associated functions called methods. Okay, so so structs do have methods to specify behavior associated with a struct type. Struct and enums are the building blocks for creating new types, blah blah blah. Okay, cool. So yeah, forget everything I said. Structs can have methods in Rust as well. So, defining and instantiating structs. Okay, yes, structs are similar to tuples. They both hold multiple related values. like tuples, data in structs can be of different types. Exactly. Unlike with tuples, in a struct you'll name each piece of data, so it's clear what the values mean. Okay. Oh, you don't need to rely on the order of the data to specify or access the values of an instance, and also you can actually understand what's going on. To define a struct, we enter the keyword struct and name the entire struct. A struct name should describe the significance of the pieces of data. Okay, and we call these fields. Okay, for example, we have this user, which has an active field, username, email, and how many times he's signed in. Okay, yeah, pretty straightforward so far. So this will be the name of the struct, and you can access fields, I guess, in with a dot, but we will see that later. So after we define a struct, we can create an instance of it by specifying concrete values for each of these fields. And we use these keyed column value pairs. We don't have to specify the fields in the same order. Nice. It's like a general template for the type. Okay. Yeah, I would say let's try to create one of these things. Should we overcomplicate our calculator for this? What do I have opened here? By the way, I have multiple terminals. Okay. Should we overcomplicate? Yes. Should we overcomplicate our calculator example? I would say yes. Let's do that. So let's define a new struct, which is called operation, and an operation as a operation. So it's kind of sad that we need to reuse the same name, but I don't want to spend time thinking about a better name. So we have an operation which is a string, and then we have first operand, which is integer 32. And we need do we need commas? We do need commas. Okay. And then we have a second operand. Okay, and basically, okay, now we have our type. Actually, let me put this comment above everything, so it's a bit easier. Okay. Of course, this would be an enum. Maybe we can add it as an enum once we arrive to enums. Yeah, it's in the next macro chapter. Okay, and so basically what we want is to, instead of doing this, we can have our new function, which is called get operation, for example. It takes no arguments because we're going to ask everything to the user, and we return an operation struct. And its code is going to be pretty much exactly this, but we'll return a new operation. And so let me see if I remember correctly. The last expression in our Rust function is actually what the function will return. So I can just create an operation on the fly, I think, with the operation being operation, and with first operand being first operand and second operand being second operand. And then, so instead, in the main function, instead of asking everything here, I'm going to say that operation equals get operation, and we are going to match on the operation dot operation. I guess it's with a dot that we assign. So we already know that we can do blah blah. We can use this dot to access values. So basically this is gonna be something like this. Okay, let me shrink this. Okay, so let's see if this does make sense. So basically what we are doing is we are defining a new struct, which is an operation, which is basically like a set of fields that represent a single operation. So we have the operation we want to perform, and we have the two operands. So this we could call it a binary operation actually, so that we don't have this. No, okay, let's just call it operation. It's fine. And then in our main loop, we get the operation by asking the user. So we ask the user we prompt the user for the string operation. We read the input, we trim it, and we store it as a string. We read the two operands as we did before, and then we return our operation, and then we do exactly what we did before. Actually also here we need to add the operation. So this is becoming really long. Too long. Can I sum? Okay, let's just not complicate things. I mean, we know what this function does. Let's see if I can actually compile this. How should we do it? Let's do it like this. So now, whoa, okay. So let's see, how many errors can we have in a single execution? My laptop doesn't like when I try to resize windows. It's really struggling. Okay, so not supported in format string. Okay, so let's construct this string then. Actually, let's add a method to operation. Okay, so let's not print this yet. So what we are gonna do later is I want to add a toString method. So to do add a toString method to operation. Okay, and then we can print the result. Okay, we can do that later. So at the moment, let's just focus on getting this compiled. Okay, so the problem is that this is a string, but what we actually want, and I guess also when I create it, operation is not a valid operation. Yes. So let's remove this as well. Let's remove this from here because I don't want to deal with this problem right now. And let's just try to see if I can actually solve this in a nice way. Okay, so this of course is wrong. We know that this trim returns a slice of a string. A slice of this string actually. So what was the problem? What was the problem again about this string slice? So can I actually? So I need to basically convert this back to convert this slice to a string. Otherwise, wouldn't I need to return this string here from this method as well? So let's just simplify this and let's just see if I can convert. So what we want is Rust convert string to string. Actually, I want to convert a string slice to string, and actually vice versa. Convert a string. No, I want the opposite. Vector. What is the automatic way to convert a string to a reference? String slice from string. No, string slice to string. Okay, let's see if this can be directional. So is it correct that in order to get a slice from a string, the variable, there is no difference between, okay. Is it correct in order to get a string from a reference to a string, there is no difference, okay. string from which intercross. Okay. Yes. Okay. Of course, I could just do this actually. So let's just wrap this in a string from. Okay, and so this will fix the first compiler error, right? No. Wait, 45, yes. So why not? Actually, this is, okay, no, it didn't use the latest code to compile. What? Yes, exactly. And what we want to do is to create a slice. We should know how to do this. So we have this string. We want to create a slice from it. I should remember how to do this. Let's see. Blah, blah, blah. Blah, blah, blah. Okay. So, and if I want the entire slice, I can just do this. Okay, so we want to get the entire slice. Let's see. Yeah, so I mean, at least this seems to be working. Let's see if I can actually run it once. Yes, of course we are not printing anything yet because I want to add a toString method to operation, and then we can print that. Okay, moving on. Let's go back to defining and instantiating structs. So we already saw how to create one. We are actually creating one here. Note that the entire instance but must be mutable. Okay, if I want to reassign it, of course, but we definitely don't want to reassign anything. So yes, so if this is also another very interesting thing, that if you want to change one of the field of the struct, then you need to basically mark the whole struct as mutable. This is very, very interesting. Note that the entire instance must be mutable. Rust doesn't allow us to mark only certain fields as mutable. As with any expression, we can construct a new instance of the struct as the last. Yeah, this is exactly what we did. Okay, show a build user function, return the user instance with the given email and username. The active field gets the value of true. Okay, this is basically showing how you can have like default constructors and these kind of things. Okay, it makes sense to name the function parameters with the same name, of course. I mean, this is just a basic, like not very specific to Rust, just a very good convention. Oh, this is also I like using the field init shorthand. Okay, so basically, if you have a method that builds an operation, and you can just like if here for example. So what happens is that if you pass a field here, and to initialize the if you use a variable to initialize a field which has the same name, you can just remove it, making it much nicer. So let's see if this is true. I trust the book, but trust but verify, you know. So let's run it again. Yeah, it does compile. Very cool. So this is, I think in JavaScript you can also do this. Interesting. I like it a lot. And actually, maybe we can even shorten this a bit, so we don't. Can I do this? Is this allowed? Can I just trim the operation here? I think so, because this is just a slice from this string, and so this is absolutely valid. And then I create a new string from this slice. So I think this is also valid. Let's see. It is nice. So we can have a bit more symmetry here. Okay, let's move on. So this is nice. Creating instances from other instances with struct update syntax. Okay, it's often useful to create a new instance of a struct that includes most of the values from another instance, but changes some. You can do this using struct update syntax. So yeah, basically like you want to clone a field. I think Kotlin has a clone method to data classes or something, in which you can basically just specify which of the fields you want to override. and it will just take use the value that the class currently has for all the others, for all the ones you didn't specify. So for example, in this case, what are we doing? We have a user1 and we want to create user2, which shares everything but the email. So okay, but we can, oh nice, using struct update syntax we can achieve the same effect with less code. Wow, but this really looks like JavaScript. Like, I think also JavaScript has this destructuring or whatever it's called syntax. Like, very cool. I wouldn't expect from like, these are very cool, like cool high-level features that I would not necessarily expect from system programming language. So nice. So basically what this does is it will take every field from user1 and override the email and create a new user2. Okay. Also creates an instance of user2 that has a different value for email but has the same values for the username, active and sign-in counts. Okay. Yeah, user1 must come last to specify that any remaining fields should get their values from the corresponding fields in user1. Okay. Note that the struct update syntax uses equal like an assignment. This is because it moves the data. Oh, okay. In this example, we can no longer use user1 after creating user2 because the string in the username field of user1 was moved into user2. Interesting. Very interesting. So it is moved. Okay. Interesting. If we had given user2 new string values for both email and username and thus only created the active and sign-in count values from user1, then user1 will still be valid after creating user2. Wow. So basically, like, depending on which field you use in this syntax, you may or may not reuse the same, like, the same user. Wow. This is very interesting. I guess this is one of those things that in practice they don't really matter, because if you write Rust for a bit, you will just never be tempted to do something like this. It reminds me of one of these cases with Kotlin, in which when you interact with Java code, like integer as the integer box value and int are indistinguishable in Kotlin, and this is usually fine, but there are some weird edge cases. Like, this sounds like one of these weird edge cases that it feels like as a side effect of how Rust is implemented, you can have this effect in which the user1 is only valid again if you didn't need to move anything, basically. Okay. The types of active and sign-in count are types that implement the copy trait. Yes, exactly. So the behavior we discussed in stack only copy data would apply. I see. So this is definitely something that I may need to read back again. Yeah, very, very interesting. Okay, using tuple structs without named fields to create different types. Okay, Rust also supports structs that look similar to tuples called tuple structs. Tuple structs have the added meaning the struct name provides, but don't have names associated with their fields. Rather, they just have the types of the fields. Tuple structs are used when you want to give the whole tuple a name and make the tuple a different type from other tuples, and when naming each field as in a regular struct would be verbose or redundant. So I really... yeah, I guess this is maybe because I just never had this chance to use this in any other programming language. This seems a bit like, why would you offer me this ability? Like, it seems that when do you actually... Oh, I see. Maybe for... Okay, they do have a point that for these structs, which they have a very, very like common way of being represented, like a color everybody knows that is this RGB colors or points. You have your 3 dimensions. So like they picked really the most common like examples. I am a bit skeptical that this in real life would be used much. This sounds like a forgettable feature, but what do we know? And then that you can destructure them into the individual places. You can also dot followed by the index to access an individual value. Yes, okay. unit-like structs without any fields. Okay, you can also define structs that don't have any fields. These are called unit-like structs because they behave similar to the empty tuple, the unit type that we mentioned in the tuple type section. Unit-like structs can be useful when you need to implement a trait on some type but don't have any data that you want to store in the type itself. Okay, we discuss, okay, basically a trait is a type that you want to implement. Okay, a unit struct name always equal. Okay, basically you can define a struct without any fields, which does make sense. You can, it's the same as in Java, like you can define a class without any field, without any method. You can just have an empty class. Sometimes it's actually useful. I think I saw some types defined. For example, the void type in Java. I'm not sure how it's implemented, but it's basically a class that has no methods, no fields. We wouldn't need any data to implement that behavior. Okay, blah, blah, blah. Ownership of struct data. Okay, in the user struct definition, okay, similar to this, we use the own string type rather than a slice to a string. This is a deliberate choice because we want each instance of the struct to own all of its data and for that data to be valid for as long as the entire struct is valid. Good point. It's also possible for structs to store references to data owned by something else, but to do so requires the use of lifetimes, a Rust feature that we'll discuss in chapter 10. I think this we saw like with this static lifetime or whatever. So yeah, definitely something that that we can leave for later. Lifetimes ensure that the data referenced by a struct is valid for as long as the struct is. Let's say you try to store a reference in a struct without specifying lifetimes. Like the following, this won't work. Okay, so what are we doing here? So these are string literals or string slices. And so the compiler will complain that it needs lifetime specifiers. Okay. I would have expected this to work, to be honest, because it's like a slice on the, like in the binary blob that contains all this data, right? Consider introducing a name. Okay. Yeah, so this syntax, I believe we saw it already. This is the most, like the ugliest thing I've ever seen. Okay. But we will see in a later chapter. So, an example program using structs. Too bad, we already have one. To be honest, I would much prefer to see methods. When are methods coming? Oh, later, okay. I guess we can just read this without actually writing any code. And then we can add methods to our operation struct. Okay. Let's write a program that calculates the area of a rectangle. We start by using single variables and then refactor a program until we are using struct instead. Okay. So we have our width, our height, that are integers. And then we have our function that takes our width and our height and returns the area. And this works quite nice. This code succeeds, blah, blah. The issue with this code is evident in the signature of area. The area function is supposed to calculate the area of one rectangle, but the function we wrote has two parameters and it's not clear anywhere in our program that the parameters are related. Yes, it would be more readable and more manageable to group width and height together. Okay, yeah, makes sense. So we could use a tuple basically, yes. So we pass a tuple of two unsigned integers and we multiply each with each other. But then again, you can make the argument this is just a tuple of two unsigned integer. What do they even represent? Maybe is maybe are dimensions, maybe are like x and y coordinates or whatever. So we want to have a type, and so we create our rectangle struct. And then we instantiate. We create one instance of such rectangle. We change our code for area to accept a reference to a rectangle, and then we just return the product of its fields. Okay. It be useful to be able to print an instance of rectangle. Oh, actually, yes, this was actually useful after all. While we are debugging our program and see the values for all its fields. Listing blah blah. So we are exactly this. This is what we are trying to do. Is we are trying to print a rectangle as we did, as we wanted to do for operation, but this will not work. Does implement standard format display. I wonder if. No, okay, we got a different method because we are trying to print fields. Okay. Oh, I think I saw this thing that we're about to add. Let's see. The println macro can do many kinds of formatting, and by default the curly brackets tell println to use formatting known as display. Output intended for direct end user consumption. Okay, the primitive types we've seen so far implement display. Okay, so basically, if we want our operation to be printed to be represented as a string, we should also implement this display trait. Okay, but for structs, of course, we have no idea how they should be formatted. Okay, so Rust doesn't try to guess what we want. And struct don't have a provided implementation of display. For example, this is something that Kotlin does differently, right? Like with data classes, you absolutely do get a default toString implementation, for example. But anyway, okay, so one of the error is, of course, you don't contain display. Note in format strings, you may be able to use this format for pretty print instead. So what does it mean? The println macro call will now look like println. Okay, put in the specifier inside the curly brackets tell println we want to use an output format called debug. Okay. The debug trait enables us to print our struct in a way that is useful for developers, so we can see the value while we are debugging that code. Okay. Oh, so this thing I saw. This thing I saw already somewhere. I don't know. So Rust does include functionality to print out the debugging information, but we have. Okay, so basically this is a shorthand to implement a trait, right? Is it just like a macro basically? Like you add it here and the Rust C will just add a bunch of methods to implement the debug. Rust does include functionality to print out the debugging information, but we have to explicitly opt in to make that functionality available for our struct. To do that, we add the outer attribute just before the struct definition as shown here. Adding the attribute to derive the debug trait and printing the rectangle instance using debug formatting. And when we run the program, we won't get any errors and we'll see a nice output. It's not the prettiest output, but it shows the values of all the fields for this instance, which would definitely help during debugging. Okay, it's useful to have output that's a bit easier to read. In those cases, we can use another format for println. So this is very cool. So let's try. I still do want our toString method because this toString is not going to be used for debugging. I actually like a specific reason to we should still we shouldn't have the toString method. We should implement the display trait. But I guess first we will add the toString method and then we will implement the trait. Because printing the operation to standard output is not like a debug information, is actually what this program is supposed to do. And so using this debug thingy is not actually correct. So let's see. So what was this format again? And then we pass the operation, right? So let's see. Does this work? Yeah, sorry, I need to actually run this. Yeah, we see our very nicely formatted operation. Should I increase the size of this terminal? Okay, maybe yes. Yeah, sorry, I guess it was a bit too small before. fix it. Okay. Another way to print out the value format is to use the debug macro, which takes ownership of an expression as opposed to print line that takes a reference, prints the file and the line number of where that debug macro also occurs in your code. Okay, so debug is basically like to actually, yeah, it does what it says, like to debug your code. Instead of putting print lines around, we can put debug around the expression, okay. Returns ownership of the expression value. That with field will get the same values if we didn't have the debug called there, yes. We don't want debug to take ownership of rect1. So this is actually useful, and I think if it also like prints the line number is also cool. Okay. Okay, there are more derivable things that look cool. Okay, and then we want to add methods. So methods are similar to functions. We declare them with the fn keyword and a name. They can have parameters and a return value, and they contain some code that's run when the method is called from somewhere else. Some code that's run with the method. Okay. Unlike functions, methods are defined within the context of a struct, or an enum or trait object, blah blah blah. And the first parameter is always self. Okay, like in Python basically, or like yeah, this is one of these languages in which I saw that like the what in Java you would call this in methods is actually explicitly passed as self, which I actually don't hate. Oh yes, this I remember. I think for the very first Rust program that I wrote, I did do something like this. So basically, to define methods on a struct rectangle, you need to like wrap it in this implementation thingy. I wonder why. Wouldn't it make sense to just oh, I guess this allows for the syntax with the dot. Okay, because like otherwise I would like, wouldn't it be nicer to just do what I think Go does? Like, I don't know, this implementation thing is not, I'm not a fan. And so, okay, so this is very interesting. So what would a toString method look like for operation? So we have our implementation of operation, and actually a better method for operation would also be like something like compute or whatever, or like solve. So solve, what does it do? It takes self and it returns an integer 32, and basically it does this, right? So yes, and actually we don't even need the result field, we just do this. This should return an this is an expression, so we return the result of this expression. And I wonder, how do I access, with self. Okay, so basically we can replace this with self. Whoa, what did I do? With self. And now that I have an operation, I can see, I can do something like, okay, operation.solve. And this looks much nicer. Although I am not sure I like binding the data and with the methods in this way. Maybe this is fine. I don't know. Maybe this is fine. And now there is a like an argument for what should toString actually print. Like, should we resolve it, like, I don't know, let's call it pretty solve. And basically what this method does, this method will return a string, which basically first we calculate the result, which is actually no, the result is just self.solve. right? And then we return a new string. How can we do this? So like output is a string new. Was it new? And then output dot append. Let's see. No, not here. Rust string builder. 7 ways to concatenate strings in Rust, because 1 was not enough. Okay, let's see. It's a GitHub link. Oh, it's a benchmarking thingy. Okay, what the? Okay, yeah, like what? I just want a new string. New, yes. Oh, push string. Okay. And of course, this will gonna be a problem because what are the methods to string? Maybe I can push. So Rust string. I want to push not a string, but like integers, right? Let's see. Do you have a push integer, push number? No? What pushes do you have? Push string. Push string. You only have push string. I mean, come on. Okay. Rust string push integer number. How to push string in string? Not. How do I convert an integer into a string? Yes. Another x to string. Okay, nice. So we can do self.first operand to string, and then we have space. I mean, there is for sure a better way to do this. And then another space, and this, and then equals, and then result. So this is result. This is the operation. Operation. And this is the second operand. And then we return the output. Wasn't there a nicer way to do this? Well, I mean, I'm sure there is a nicer way to do this, but let's just... also, maybe I should have finished this first, but too late now. Let's see if this thing compiles. Do you compile? Of course you don't compile. I mean, what was I expecting? Let's see, there are many errors here, so let's simplify a bit. Oh, yes, of course. Consider borrowing here. Oh, because, okay, I see. But wait. What happens? I guess I can borrow freely inside like self will not, like I can borrow whatever here, right? Because anyway, the self will not go out of scope after this. So, and also push string will probably like copy. What the fuck am I even talking about? If it's a reference, it should always work, right? Let's see. Like something like this. You might have meant to use the what? Okay. Oh, of course. I forgot a few semicolons. Thank you, Rust, for making me write all this useless stuff. Operation, help, you might have meant to use the available field self.operation. I did mean that. Thank you very much. This is exactly what I wanted to do. Do I even need this? Yes, because I need to create a slice in this case. Okay. Whoa, cannot borrow as mutable. Oh, of course. So obviously, this is a mutable string. because we need to write into it. Nice. Okay, so now this compiles. Am I moving around too fast? Probably, but yeah, too late now. So what I want to like print is like I want to print the result, and I want to, so we print result. So now result is going to be a string, and then I can just print result. Let's see. Let's sum 1 and 2. Wow, amazing. Love it. Okay, I guess we know how to use methods somehow, but let's read a bit about them. So we use an implementation block for rectangle. Okay, then we move the area function with its implementation. We call it to call area. Okay, we already basically know everything here. If this in the signature for area, we use like reference to self instead of rectangle, reference to rectangle. The reference to self is actually short for self is. Oh, okay. So does this work for everything? Like if I wonder if this syntax works, for example, if I have a reference to a string that I call string, do I need to specify the type? Anyway, the type self is an alias for the type that the impl block is for. Okay, methods must have a parameter named self of type self for the first parameter, so Rust lets you abbreviate this with only the name self in the first parameter spot. Note that we will still need to use the ampersand in front of the self shortened to indicate that this method borrows the self instance. Okay. Methods can take ownership of self, borrow self immutably as we've done here, or borrow self mutably, just as they can any other parameter. Interesting. So for example, if we had a solution like field here, I don't even know, does Rust even have a null or whatever? Like what would I need to, I would need to wrap it to like an optional or whatever. And then you want to have the solve function, instead of returning the result, you want to mutate the, self so that it writes the result here, like as another field. Then you would need to use mutable reference to self. Interesting. I am not sure why would you want to borrow self, but maybe they will explain it later. So we've chosen a reference to self here for the same reason we used reference to rectangle in the function versions. We don't want to take ownership, and we just want to read the data in the struct, not write to it. If we wanted to change the instance that we've called the method on blah blah, we'd use a mutable reference to self as the first parameter, of course. Having a method that takes ownership of the instance by using just self as the first parameter is rare. Yes, I could also imagine. This technique is usually used when the method transforms self into something else and you want to prevent the caller from using the original instance after the transformation. Interesting. So yeah, basically it's a self-destruct thingy. Like you borrow self, you return something else, and then poof, you cannot use. You cannot call any more methods on this instance and whatever. Interesting. So the main reason for using methods is the functions, in addition to providing method syntax and not having to repeat the type self in every method signature, is for organization. We put all the things we can do with an instance of a type in one impl block rather than making future users of our code search for capabilities of the rectangle in various places in the library we provide. Yes, this makes sense. So I cannot have two implementation blocks. Like, can I add something else for operation? Like, I don't know, hey method that returns. I cannot write an integer which is the number 3. Would this Would this compile? Where is my terminal? Here. Would this compile? It would. But then I can absolutely scatter things around the code base, right? I can have this in another file, or maybe is it you can only do it in the same file? We still don't know how to have multi-file program, so if I remember, I will try when we get there. Okay, know that we can choose to give a method the same name. Okay, yes. For example, we can have the with method, okay, for some stupid reason. Here we are choosing to make a with method return true if the value of instance with is greater than 0, and you can have the same name. Often, but not always, when we give methods with the same name as a field, we want to only return the value in the field and do nothing else. Methods like these are called getters, and Rust does not implement them automatically for struct fields as some other languages do. Getters are useful because you can make the field private, which we don't know how to do yet. Does private here works? Is it a keyword in Rust? It's not. Okay, we're discussing what public and private are and how to designate field or methods as public or private in chapter 7. Okay, so yeah, I mean, this is bringing me back Java vibes. Getters and setters are horrible. Really a waste of screen space. Of course, they do serve a purpose and whatever, but just use auto value, and just use auto value. Just have everything immutable. You don't need set in like 99% of the cases. So no need to have setters for sure. And if you only use immutable stuff, you don't even need to have getters probably. I know that it looks ugly in Java, so just use auto value and just forget about getter and setters. So where's the arrow operator? What do you mean? Where's? In C and C++, two different operators are used for calling methods. Ah, okay, I see, okay, yeah, sorry, this is my ignorance as a Java developer, because I thought this arrow thingy, I don't know if it has even a name, was just this thing. Okay, but yes, in C, you can use this if you have a pointer or whatever, if I recall correctly. If you're calling a method on the object directly and blah, 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 if you're calling the method on a pointer to the object. Okay, yeah, sorry. In C++, you use dot if you're calling a method on the object directly, and this arrow thingy if you're calling the method on a pointer. In other words, if object is a pointer, object arrow something is similar to deferencing object and then calling something. Okay. Rust doesn't have an equivalent to this operator. Rust has a feature called automatic referencing and dereferencing. Calling methods is one of the few places in Rust that has this behavior. Here's how it works. When you call a method with object.something, Rust automatically adds &mute or star, so object matches the signature of the method. In other words, the following are the same: p1 distance &p2. So this is basically dereferencing p1, dereferencing. Wow, what is it? Dereferencing, I think, p1, and then calling distance. Okay. This automatic referencing behavior works because methods have a clear receiver. Oh, I see. This is because of the type. Oh, now I understand. Because you need to create a reference to p1 to call the type, right? For example, to call solve, it accepts a reference to solve. So you would need to create a reference to it, but Rust basically does it for you. Rust can figure out definitively whether the method is reading. So it would use &, mutating, or consuming. The fact that Rust makes borrowing implicit for method receiver is a big part of making ownership ergonomic in practice, yes. Okay, now I understand. Okay. Methods with more parameters. Let's practice using method by implementing a second method on rectangle. This time we want an instance of rectangle to take another instance of rectangle and return true if the second rectangle can fit completely on the within self. Otherwise it return false. That is, once we've defined that can hold method. Okay, so basically we're gonna compare width and heights to see if they can, if one rectangle can hold another one. Okay. Yes, and in this case, for example, we create 3 rectangles, and of course rectangle 1 can be can hold rectangle 2, because the rectangle 2 has a smaller width and a smaller height, and but it cannot hold rectangle 3 because it has a bigger width, basically. Okay, we know we want to define a method, so it will be within the implementation rectangle block. The method name will be canHold, and it will take an immutable borrow of another rectangle as a parameter. Why wouldn't it take okay, yes, okay, sorry, I thought this was called a reference. Isn't it called a reference? But anyway, an immutable borrow, maybe they are synonymous. We can tell what the type of the parameter will be by looking at the code. Okay, yes, we pass this an rectangle, which is an immutable borrow to rect2, okay? An instance of rectangle. This makes sense because we only need to read, yeah, of course. Okay, but this is pretty straightforward. Basically, yes, we are returning self width is like greater than other width. I would argue maybe greater or equal would be more like, I don't know, for some definition of holding. And height, self height is bigger than other height. Okay. Okay, methods can take multiple parameters that we add to the, yeah, okay, and the thing to notice is that basically, yes, you will add these parameters as you would do with any other function. Okay, let's see what associated functions are. So all functions defined with an imp block are called associated functions because they are associated with a type named after the implementation. We can define associated functions that don't have self as the first parameter. For example, yeah, exactly this is what I was thinking. Like if you want to have like a builder method that basically create operation, like create operation that returns an operation. Maybe you want to do it here, like I don't know, blah, something, blah. And makes sense to stay inside the implementation. So this and it wouldn't have a reference to self as an argument. So this would be more like a static method in Java. And in fact, we can see the syntax, which is kind of look like a static method in Java, like you call it on the type basically with this other syntax. But instead, this doesn't mean calling this on the string type, but it means in the string namespace, right? Associated functions that are in methods are often used for constructors. Yeah, okay, exactly what I said. That will return a new instance of the struct. These are often called new, but new isn't a special name and isn't built into the language. For example, we could choose to provide an associated function named square that would have one dimensional parameter. Oh, interesting. And then return by the way, this is also cool. So you don't need to say operation, you can say self. Interesting, but yeah, sorry, I am like going off a tangent. So basically, yes, you can have a square function that returns a rectangle that has the same width and height, okay, and you don't need to call it new, basically. And we use this syntax to, yeah, exactly what I said before. This function is namespaced by the struct. The colon syntax is used for both associated functions, and namespace is created by modules. And we will discuss modules in a later chapter. Okay. Oh, this is also what we tried before. Each struct is allowed to have multiple implementation blocks. For example, okay, yes, you can have more. There's no reason to separate this method into multiple implementation blocks here, but the syntax is valid syntax. We see a case in which multiple implementation blocks are useful, where we discuss generic types and traits. Okay, summary. Okay, we don't need a summary. But I wonder then what, like, because before we said something like, oh, like you wrap everything in an implementation block so things are together and not scattered across your code base. But since you can have multiple implementation blocks, you can just have multiple implementation blocks in like different files. So I'm not sure I agree. And I believe that's it for today. Wow, we are like 5 seconds short of 1 hour. Amazing. This was not planned at all. I am realizing that maybe I'm moving things on the screen a bit too much. It might be a bit hard to follow. Yeah, I hope that the audio this time actually worked a bit better, that you could hear something that I said and that you could follow along. Did we actually try that this works? Yeah, we did. Yeah, I also like this format in which we have this stupid program and we are adding more and more features. Not features. We are using more and more Rust features to actually write it. And actually, this is also a good example of over-engineering, because I think it's actually longer than it was before and more complicated, but by using more language feature. I mean, obviously, we don't need this operation struct. But yeah, cool. I am really enjoying Rust so far. I think it's a really great language. There are a few small things that I find a bit weird. But overall, really cool. Doesn't seem too hard to use so far, or at least it's not giving like living up to the hype that Rust is hard, or like somewhat hard. It has so many like little features that I didn't expect a system programming language to have. Like this thing that you can like create a struct with a previous order struct and whatever, which is like a very JavaScripty thingy to have. So yeah, pretty cool. As I said, I will go to a meetup, a Rust meetup on Wednesday. I'm very curious how much I will be able to understand. I will definitely let you know. And yeah, have a good weekend. And that's it for today. Also, yeah, one last thing. So I will definitely stream next week as well. I am trying to post before when I will stream, but it's a bit, yeah, I cannot commit to a time yet, because like this is such a random thing, a random side project for me. But for sure I will try to basically stream at least twice per week for the next few weeks. I might need to skip for Christmas or New Year's or whatever, or maybe not. We will see. And